Now using that information, let's try to solve this problem. Example 1. So here are the 3 pizza companies that we've looked at before, Papa John's, Domino's, and let's say Pizza Hut. And it says find the correlation between grams of fat and cost. And I think these, because I think these are for whole pizzas, and so let's make this $17.50. Let's make this $18 and $20 because it's really cheap to have a $1.75 pizza. And it would be ridiculous to have 100 grams of fat in one slice of pizza. So, all right. So if you look at the examples provided in the download below, we could use this data in order to find a correlation coefficient. So in order to find correlation coefficient, I like to sort of break it down into the component pieces. And the big component pieces I'm going to need are the z-score for x and the z-score for y, right? And I'll say the z-score for fat and the z-score for cost. So z-score for fat and z-score for cost. In order to find the z-score, I would need to put in the difference between this and the average, right? One thing that might be easier is if we actually just create a column for averages, because we're probably going to need this again and again. So why don't we go ahead and get those averages? So I'm just getting the average cost as well as average grams of fat. And I'm just going to color it in a different color so that we know that this is an entirely different thing here. All right, now that we have that, now it'll be easier for us to find the z-score for fat. So here we want to get x, our fat, minus the average. And we probably want to lock that in place. Oops. And we want to divide that by standard deviation. And the nice thing about Excel is that it already has a function for standard deviation. And this one will give us the n-1 version, right? So I can just take this data, keep overshooting. And I want to lock that data down. I don't want that to move. Right? Actually, I probably want to copy it over to E later, so I'm just going to unlock the B part. As long as I stay in the same column, as long as I stay in column D, it'll use column B. But if I move over to column E, it should use column C, right? So let's try that. So here we see that z-score is -1, that's 0, and 1. And that makes sense. Your z-scores totaled together should roughly equal 0 because you're getting how many distance away on the positive side, how many distance away on the negative side, and they should balance out if you really have the mean. And so let's check this formula. Yep, it's using B3, but it has the average, and it's getting that standard deviation. Perfect. All right. So once I have that, I could actually just copy and paste this over here. And here we see, now it's using C and this average and getting the standard deviation of this data. Perfect. And we see roughly, the negative side adds up to the positive side. Okay. So now that we have these individual z-scores, now we need to get the z-scores for fat multiplied by the z-score for cost. And that's real easy. This times this. For every single data point or case that we have. And we have 3 cases here, the 3 different brands of pizza. Right? Once we have that, instead of the average, well, actually, we could just get the average all at once because we could just put it all in one formula, right? We could just sum these together. could sum those together. And we want to divide by n minus 1. In this case, it's 2, right? If you wanted to put in a formula, you could put in count minus 1. But I'm just going to put, for our purposes, 2 here. Okay. And here we get a very, very high correlation, where it's very, very close to 1. As cost goes up, z-score goes, as cost goes up, fat goes up, right? As cost goes down, fat goes down, right? And so they have a very positive correlation, and it's very liney. It adheres very closely to the line, right? And so here we could see that that this data is very, very highly correlated. It has a strong correlation. We don't have a lot of points, but apparently they fall very, very close to the line.